Distance, position, and displacement. Let's do two sample questions. There are two formulas you can use to calculate displacement. First, the meaning of displacement is change or difference in the object's position. So when you compare the final position by the initial position, you are really just subtracting the two. So when you take the difference between where your object is now compared to where your object was before, this is actually change in position, which is literally what displacement means. Second formula, you're just adding up a series of displacements that the object made. So the object made some changes in position that happened one after another, and you could just add them up to get your total displacement. We will practice examples of both. Here's our first example. Bob starts 10 kilometers north of the school. He then travels 20 kilometers south, then 12 kilometers north, and we are going to assume that the school is the reference location or origin. And we will find the initial position, Bob's final position, total distance, and total displacement. It's always a good idea to include a labeled sketch. So pause the video now and see if you can sketch the information in the question. So here's a sketch. Where I wrote school, there's a zero there to indicate that this is our position 0. This is our reference position. All other positions in this story will be compared to that school position. So I put a number 1 over here because this is where Bob is right now. He is 10 kilometers north of the school. On my diagram, north is a direction to the left of the page. And I'm letting north be a positive number. So when I write something like this with an arrow, square bracket with north in it, and I put a plus sign on top, this is a symbol that I put on my diagram that tells you that the left side of the page is north, and I'm making north positive. So this is grid paper, and you can just use every box on the grid as 1 kilometer. But you don't have to, it can just be a sketch. So this is more like a scaled diagram. Okay, this arrow going to the left is really just the position of Bob where he is right now. And then he moves 20 kilometers south. So here's an arrow from the from the same position, number 1. From number 1 to a new position 2, we're going to the right on the page, which means we're going south. This represents our 20 kilometers south, that movement. And then the third movement, we have our, we're going from position 2 to position 3. And that is a 12 kilometer movement to the north again. So you end up just drawing lines but basically these are arrows, show the direction of the movement, show what's happening. At the end points of the arrows, you have positions. So one of the first questions we can answer is, what is the initial position? Because that was the first sentence in the question. This is the symbol for initial position. The I is the subscript for this position, is a vector, and you have a little arrow on top. So initial position for Bob, 10 kilometers north. That was given in the question. And that's represented by this dot right here.